Hello guys, in this video we are going to discuss the solution of the problem minimum steps to this destination. So let us look at the problem statement. The problem statement says that given an infinite number line, you start at 0 and can go either to the left or to the right. The condition is that in the ith move you must take I steps. Given a destination D, find the minimum number of steps required to reach that destination. So let us try to understand the problem statement with the help of an example. So let us say the destination which is given to us is 2. Then we are starting from 0, and from 0 this is the first step which we are taking. So the first step which we will take is +1. So remember, we can go to either +1 or -1. So let us say the first step which we took is +1, which is equals to 1. And then the second step which we took is -2, because of which we went to -1. And the third step which we took is +3. And once we took +3, this becomes equals to 2. And we reach our destination. So this is the destination which we wanted to reach. So the number of steps which we took is, the number of steps is basically 1, 2, and 3. So in this case, we are going to return 3. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to solve this problem, what we are going to do is we are going to keep on adding the numbers corresponding to the steps. We will not worry about the negative numbers yet. First, what we are going to do is we will just go ahead and add all the numbers. So in the first step, the number of steps I can take is 1. In the second step, the number of steps I can take is 2. Similarly 3, and so on. And we will keep on doing this, let us say, for n times. Now, it might be possible that after doing it for n times, we achieve our target. So let us say the target is given, and just by adding the numbers, we are able to get our answer. In which case, we are going to return n, and n will be our answer, the number of steps. So this was our case 1. Or where the target can be achieved just by adding the numbers all the way till n, in which case we are going to return n. Now the second case is where the sum of the numbers exceeds the value of target. So for the cases where it exceeds the value of target, how do we solve such cases? Well, in order to solve such cases, let us first understand a concept. So the concept is essentially, let us say the sum of the numbers is represented by sum. So 1 plus 2 plus 3, and let us say there is some intermediate number x, and then all the way till n. And let us say this sum is something which I am representing by. Now this sum is something which I can also represent it as y plus x, where y is equals to 1 plus 2 plus 3 plus dot 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 x plus dot 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 n minus x. Right? So what do I mean by this is that y is equals to sum of all the numbers except x. Once we have this equation with us, we can represent y is equals to sum minus x. So let us say this is our one equation which we have, where y is equals to sum minus x. So over here, sum is equals to 1 plus 2 plus 3 plus dot 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 plus x plus dot 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 all the way till n. And over here, let us say in order to reach to our answer, we need to flip the sign of this value, right? So we need to flip the sign of x, right? So please note, it might be possible that x is a low number, or it might be possible that in order to achieve to our target, there are various numbers which we need to be flipped, in which case x is the sum of all those numbers. So let us say we need to flip 3 numbers or any amount of number. So in such cases, x will be the sum of all those numbers. Okay, I'm representing all those numbers or a lone number by x. If by flipping the sign of x, we are able to achieve to our target. So once we have flipped the sign of x, so the new sum will be equals to, so the new sum will be something like this, and this will be minus x since we have flipped the sign, and this will be all the way till n. And so the sum, or the new sum rather, So this is my new sum. New sum will be equals to all sum of all the numbers except x, and the sum of all number except x is given by y minus x. So this will be by new sum, in which case new sum, and let us represent new sum in the form of old sum. So y is equals to, so from our equation 1, y is equals to sum minus x. So let us plug that value. So y is equals to sum minus x and then minus x. So the new sum will be equals to sum minus 2x, right? So this is one very important concept which we need to understand, and this concept is what we are going to use in order to come to our solution. So this is a very important concept which we need to understand. And by the way, this new sum is our target, right? So remember, over here I have flipped the sign of x, and by flipping the sign of x over here, so I have flipped the sign of x, and by flipping the sign of x we were able to reach to our answer. And then I have computed my new sum, which is equals to y minus x, and then I have substituted the value of y, which is sum minus x, and that is how I got my new sum equals to sum minus 2x, which is essentially our target. So the concept which I was trying to explain from here is, if we flip the sign of a number x, then the new sum will be sum minus 2x. So having understood this concept, now let us solve our problem. So we were discussing the case where the sum is greater than target. So let us discuss this case. So over here, our sum, so sum equals to 1 plus 2 plus 3 all the way till n. Our sum is greater than target. Now since sum is greater than target, so let us compute the difference. Well, the difference will be equals to sum minus target. Now with this, there arises two cases. So this is my case 2.1, which is within case 2. This is the first case where the difference is an even number. Now if the difference is an even number, then sum minus target will be equals to 2i, right? Since this is an even number and this is how we represent even numbers, so sum minus target will be equals to 2i, and this equation can be rewritten as target equals to sum minus 2i. Now let's call this equation as the second equation, and I want to compare this second equation with the concept we have just discussed. So let us go back to the concept. Well, from our concept, what we have understood is target is equals to sum minus 2x. So now let us draw the parallel between second and third equation. So over here also target equals to sum minus 2i. So that simply means 2i, or I, is the number whose sign needs to be flipped. Okay. So because of this, what we can write it down is I is equals to sum minus target divided by 2. And in order to find out which numbers need to be flipped in order to reach to our target, when the difference is an even number. Please note, here we are discussing the case where the difference is an even number. So for the case where the difference is an even number, the number whose sign needs to be flipped will be given by this equation. So let us work with some example in order to solidify our understanding. So let us say over here our target is 11. Now in order to reach to 11, what we are going to do is we are going to sum all the numbers all the way till n. So let us do that. 1 plus 2 plus 3 plus 4 plus 5, right? On doing so, our sum will become equals to 15, and which is greater than 11. Now over here, our difference is how much? Well, our difference is 15 minus 11, which is equals to 4. And because of which the number which needs to be flipped over here will be difference by 2. So which is 4 minus 2, 4 divided by 2, which is equals to 2. So if we flip the sign of this 2, then the sum will be 11. So let us try to do that. And if we add all these numbers, so this will come as 11. Let's take one more example. So let us say this time we want our target to be 13. So again over here our sum will be equals to 1 plus 2 plus 3 plus 4 plus 5. and this is equals to 15, and 15 is greater than 13. Now the difference between sum and target is 2, so our difference is 2, and please note this 2 is an even number, and in our first example also this 4 was an even number, because of which we are able to apply this logic, right? For odd number the case will differ. So when the difference is 2, then the number which needs to be flipped will be given by 2 divided by 2, which is equals to 1. So if we flip the sign of this number, then the sum will become 13. So let us try to do that. 1 minus 1 plus 2 plus 3 plus 4 plus 5, and if we add all these numbers, then the value you will get is 13. So what is the conclusion we are drawing from here? Well, the conclusion we are drawing from here is, which is for case 2.1, which is if sum is greater than target, where sum is equals to 1 plus 2 plus 3 plus all the way till n, then the number of steps needed to reach to our target is n, right? And the number whose sign needs to be flipped will be given by sum minus target divided by 2, right? And please note over here the difference between sum minus target is even number. Let me write it down over here, and sum minus target is an even number. Please note this is for the case where the difference between sum minus target is an even number. Then only this logic holds. All right. Now let us see what will happen when the difference between sum and target is not an even number. So now let us go ahead and explore that case as well. So over here we are discussing the second case where the difference between sum and target is not an even number. So let me write it down in the form of equation. So over here diff is equals to sum minus target, and this diff is not an even number or an odd number. And as we know, sum is equals to 1 plus 2 plus 3 plus all the way till n, and our sum is greater than target. So these are the few things which we know of. Now let us see whether by flipping some numbers it is possible for me to achieve to target in this particular case. So let us say our sequence was this. So 1, 2, 3, 4, some number x, and then n. And let us say if we flip this number, right? So if we flip this number, then the new sum, as you can recall from our earlier discussion, well, our new sum will be equals to sum minus 2x, right? And where sum is equals to 1 plus 2 plus 3 plus all the way till n. So this, our new sum will be equals to sum minus 2x, right? So by flipping any number, the new sum will be equals to sum minus 2x. Now let us rearrange this equation. So 2x can be written as new sum minus sum. Now let us compare this and this equation, right? So over here difference is an odd number. So what we can also write is down is the difference is an odd number. So this will be represented by 2i plus 1, and this is equals to sum minus target, and this is what we want to achieve. But by flipping any number in the sequence, so if we flip x in this sequence, the difference we will obtain in new sum and the previous sum is 2x, right? So this, what I'm trying to emphasize over here is this is an even number. So what I'm trying to say over here is there is no way by which if we flip some numbers, we will be able to get an odd difference, right? Because the difference is always 2x, or the difference is always going to be 2x, and what we want to achieve is 2i plus 1. So since the difference will always be 2x, what we want actually is we want this difference to be an even number. Okay, so let us write it down. The difference between new sum and old sum will always be an even number. Thereby, if the difference between target and sum is an odd number, then by flipping the sign of any number, we will not be able to reach to our target. So let us understand this concept, and this is also a very important concept. And the concept is, as we know, the difference between new sum and old sum, right? The difference between new sum and old sum, and how we are getting the new sum? Well, the new sum is obtained by flipping the sign of some of the numbers. So as we know that the difference between new sum and old sum will always be an even number, and that is governed by this equation, right? So since we know that the difference between new sum and old sum will always be an even number, thereby if the difference between target and sum is an odd number, then by flipping the sign of any number, we will not be able to reach to our target. Okay, so it is not possible. So if the difference between target and sum is an odd number, then it is not possible for us to reach to our target. So if it is not possible to reach our target if the difference is an odd number, then what is our option? Well, our option is to make the difference as an even number. Hence, in order to reach to our target, we have to make the difference between target and sum an even number. So now let us see how we can make the difference between target and sum an even number. So please remember, over here we are exploring the case where the difference is an odd number, where diff is equals to sum minus target, and as we know, sum is equals to 1 plus 2 plus 3 all the way till n. So now let us see how we can make this difference a even number. So let us see how we can do that. So let us first write down our equation, which is equals to diff is equals to sum minus target. And to begin with, this was an odd number, right? So how do we get an odd number? Well, odd number can be obtained if sum is an odd number and target is an even number. Or it can be obtained if sum is an even number and target is an odd number. So let us first discuss this case where sum is an odd number and target is an even number. So let us do that. So over here we wanted to compute sum minus target, and we know sum is an odd number, and we know that this target is an even number. So in order to make the difference an even number, what we are going to do is, within sum we are going to add n plus 1 just to make the difference an even number. So now with n plus 1 also there are two cases, right? So this also can be an even number or can be an odd number. So this can be an even number or this can be an odd number. So now let us discuss these two cases. So let us plug the first case where n plus 1 is an even number. So in which case, so then we have an odd number plus an even number minus an even number. So as we know, the difference between two even number will be an even number. So this will also give me an even number, and then that even number has to be added to an odd number, which will give me an odd number, but we want it to be an even number, because of which what we are going to do is we are going to add n plus 2 as well. Okay, now since n plus 1 was an even number, so n plus 2 will be an odd number, right? So this is guaranteed. So odd number plus even number, and let me write it down over here also. So this is coming from sum, this is coming from n plus 1, and since n plus 1 is an even number, so n plus 2 will be an odd number. So this is odd number, and this is coming from n plus 2 minus even number, and this is coming from target. And if we do this, so what is happening over here? Odd minus even will give me an odd number. So this will give me an odd number plus even number plus odd number. And the sum of odd numbers, so this plus this number will give me an even number, right? So then this will be an even number plus even number, and then this will give me an even number. So let me do a quick recap over here. So we have a difference, and difference is equals to sum minus target, and we know that the difference is an odd number. Now since difference is an odd number, then the difference could be an odd number if the sum is an odd number and target is an even number. Or it might be possible that the sum is an even number and target is an odd number. So we discussed the first case, which is sum is an odd number and target is an even number, because of which the difference we obtain is an odd number, which is this case, right? Sum and target. So so target was an even number and sum was an odd number. Now, since we wanted this difference to be an even number, we added the next term of the sum, which is n plus 1. Now, on adding the next term n plus 1, with n plus 1 there are two possibilities. It could be an even number or it could be an odd number. So we explored the case where it is an even number. If it is an even number, then the equation translates to summation of odd number, even number, and then a difference of even number. Now, if we compute this, we were getting an odd number, right? Because even the difference between even numbers will be an even number, and that even number we are adding to an odd number, because of which the resultant will be an odd number. But since we wanted it to be an even number, so we added the next term of the sequence, which is n plus 2. So the next sequence or the next term will be an odd number because n plus 1 is an even number. And once we did that, our equation equates to an even number, and that is what we wanted, right? So over here, as you can see, in order to get to our solution, in sum, we have to add n plus 1 and n plus 2 for this particular case, right? N plus 1 or n plus 2 we need to add. Let us discuss the case where n plus 1 is an odd number. So let us discuss this case, right? We have discussed the even number case. Now let us discuss an odd number case. So remember, our sum is an odd number, target is an even number, and n plus 1 is an odd number. So let us discuss that case. So we want to compute sum minus target, and sum is an odd number, target is an even number, and then we have this n plus 1, and n plus 1 in this case is an odd number plus odd number, and this odd number is coming from n plus 1. Now in this case, as you can see, the sum of two odd numbers is an even number, so this will become an even number, and this is an even number, and then the resultant will be an even number. So over here, just by adding sum plus n plus 1, we get an even number. So to summarize, if difference is an odd number, then the number of steps needed is either n plus 1 or n plus 2, right? If difference is an odd number, n plus 1, and when will it be n plus 1 and when will be it n plus 2? Well, if sum plus n plus 1 minus target is an even number, then the number of steps is n plus 1. Otherwise, it will be n plus 2. And that's the whole discussion, folks. So let me just do a quick recap. I know it's been a lengthy video, so let me do a quick recap. So we wanted to reach to our target. So the first case is if sum equals to target, then return n. And remember, sum is equals to 1 plus 2 plus 3 plus all the way till n, right? The second case is if sum is greater than target. So now if sum is greater than target, we have two cases. The first case is if diff is an even number. And what is diff? Well, diff is equals to sum minus target. So if diff is an even number, then we just have to return n, right? Because just by flipping any number or just by flipping the number, and what number needs to be flipped, that is given by the equation which we discussed. So just by flipping that number, we will be able to reach to our target, because of which we are going to return n. Otherwise, if diff is an odd number, then, and here there are two cases, then if sum plus n plus 1 minus target is an even number, then return n plus 1. Otherwise, return n plus 2. And folks, that's the complete discussion of the solution. Now let us discuss the pseudocode. So minimum number of steps we wanted to compute, and D is what is given to us. So the first thing which we are going to do is we are going to have our steps. What is the number of steps in order to reach to our solution, which is given by steps, and initially its value is 0. And then we have a sum variable with us, and initially its value is 0. Now we are going to iterate on sum while sum is less than D. So while sum is less than D, we are just going to keep on adding the sum. And what is the sum? Well, the sum is equals to sum plus steps, right? And once sum exceeds D, then we have to check for even cases. Then we are going to iterate on steps till sum minus steps is not an even number. So let us say at the nth steps, the difference between sum and steps becomes an even number, then we are going to return steps, which is n. Otherwise, we are going to move forward. It might be possible that n plus 1 gives us the difference as even. Then again, we are going to return that. Otherwise, n plus 2 will guarantee to give us the difference as even number, and in that case, n plus 2 will be returned. So here we are going to return steps. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So the implementation is pretty much the same. So over here steps equals to 0 and s equals to, which is the sum, equals to 0. And we are going to iterate while s is less than d or s minus d is not an even number. And then steps will be increased by 1 and s will be increased by s plus steps. And towards the end, we are going to return steps. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.